2.5, the derivatives of composite functions, part 2. So what is the composite function? A function made of other functions. Okay. So given two functions, let's say we have f and g, the composite function f of g of x is same as f of g of x. So these two notations are the same thing. Okay, so they mean the same thing. So f is a function of g. That's what it is. Okay, and we read it as f of g at x. So let's say we have function f, x squared minus x, and function g for x plus 1. So we want to find f of g of x. Now this is going to be a composite function. So f is a function of g. Okay, so this is how we do it. So we take the g function for x plus 1 and substitute every x by that in f function. Okay, so f of g of x, so as you see I have two brackets there. Okay, and that one, the first one has a square there. So I will replace those x values by for x plus 1. So of course you can expand and simplify that, but I'm not worrying about it now. So next one, g of f, right? This means we are doing g of f of x. So this time we are going to take the f function, which is x squared minus x, replace x in g function by that. Again, I'm going to put a bracket here. Okay, I'm going to replace that x by f, which is x squared minus x. So we have 4. I have the bracket here for the x, and we have plus 1. Okay, so f is x squared minus x. We'll replace x by that. So that is g of f of x. So the next one is f of f. Okay, so f of x, they mean the same thing. So we take f function, which is x squared minus x. Okay, so we are replacing every x value in f function by that. So I have again, so first bracket squared minus the second bracket. So replace those by f x squared minus x. All right. So the next one is f prime of g of x. So we need to take then f prime, and we need to replace the x's in the f prime by g of x. Okay, so we need then f prime. F is x squared minus x, so the derivative of it is 2x minus 1. Okay, so I'm going to replace the x values in f prime by g, which is 4x plus 1. 2 times, that is your x minus 1. So replace x by, again, the g function, 4x plus 1. All right, so the chain rule. If f and g are differentiable functions, and then h of x is f of g of x, so then we have the derivative of h. We take the derivative of h like this. The derivative of f evaluated at g times derivative of g. Okay, so we take the derivative of the outside function, in this case, so outside function is f, inside function is g. So we take the derivative of outside function, we evaluate it at the inside function times derivative of inside function. I know it sounds confusing, but as we do the examples, hopefully it will make more sense. So this can be represented with the Leibniz notation. Let's say you have a function y, and it is y is a function of u. Okay, so variable for function y is u, and u is a function of x. So what do we mean with that? I'll just make up some examples here. Let's say y is a function of u. Let's say it is u cubed minus 2u. Okay, and you have function u, and that is a function of x. So u is, let's say, 5x squared minus 6x. Okay, so if you need to take the derivative of y relative to x, which is dy by dx, you can do this. You take the derivative of u. So do you take the derivative of y relative to u? So which is in this case 3u squared minus 2. Okay, and you multiply it by the derivative of u relative to x, tan x minus 6. So you end up with two different variables. So this is done usually if u and y are complex functions. So, and if you just need to evaluate it at a certain point, then you just leave it with the two variables. And we have one example later on related to that. Okay, example 2. F of x is given, it is 1 over x plus 2 squared, and g of x is given, x squared plus g. So we want to find the derivative of h, and h is f of g of x. Okay, so then derivative of h, applying this, right? We take the derivative of outside function f, we evaluate it with the inside function, times we take the derivative of inside function. All right, so f prime we need first, because we will need to substitute g function in the f prime. Okay, so we need this derivative of this. So you could use the quotient rule here, or you can write this with the negative exponent and use the chain rule. So this is same as x plus 2 to the power of negative 2. Okay, 1 times x plus 2 to the power of negative 2. So now let's take the derivative of this. So drop the exponent in front. X plus 2, keep the bracket as it is. Decrease the exponent by 1. So negative 2 minus 1 gives you a negative 3. And multiply it by the derivative of inside, which is 1. So this gives you negative 2 over x plus 2 cubed. And now we need to substitute g in this f prime. Okay, so f prime of g of x then is going to be negative 2 over, substitute x squared plus 3 for x, and that's what you get. So now first part, negative 2 over x squared plus 5 cubed times g prime. So take the derivative of g, which is 2x. So we end up with negative 4x over x squared plus 3 cubed. All right, so next one. We are given a table, as you see. we have f prime, g prime, and we have their values at certain x values. So when x is 1, 2, and negative 2. So let's say you want to find f of 1, so you do f and 1, this is negative 2. Or you want to find the g prime of 2, g prime 2 is negative 4. Okay, so that is the table. So we're going to find g of f, g of f at 1. Okay, so this means g of f of 1. Okay, they mean the same thing. So we need to calculate then f of 1 and sub that value in g. Okay? So what is f of 1? So f, x is 1, negative 2. So f of 1 is negative 2, so we substitute negative 2 in the g function. Now find g of negative 2. G of negative 2, 5. B, g of f prime of 1. Okay, so there's a prime there. So you need g of f of x, no, f of 1 prime. So we are going to apply this now. Okay, so you take the derivative of outside function, evaluate it with the inside function, times you multiply this by the inside function. So instead of having x there variable, so we calculate this for a certain value of x, which is 1. Okay, so g prime of f of 1. So first find f of 1, f of 1, negative 2. Okay, so g prime of negative 2 times f prime of 1. F prime of 1 is 5. 5. So g prime of negative 2, g prime of negative 2 is 6. So you get 6 times 5, which is 30. So let's look at C. So f of g of 2 prime again. So this one, f prime of g of 2. So you take the derivative of outside function, evaluate it with the inside function. So outside function is f, inside function is g. And you multiply it by the derivative of inside function. Okay, so first you need to find g of 2. So g of 2 is 1. So then you need to substitute 1 in the derivative, f derivative, and times it by g prime of 2. G prime of 2, which is negative 4. So now f prime of 1, f prime of 1 is 5. Okay, so you multiply it by negative 4, you get negative 20. Next one is f over g prime. So let's remember the quotient rule, right? You have f over g, so you take the derivative of numerator, multiply it by denominator, minus take the derivative of denominator, multiply it by numerator over square of the denominator. So you're going to now calculate this for x equals negative 2. So this is, if you write it with the negative 2, f prime of negative 2 times g prime of negative 2 minus g prime of negative 2 times f of negative 2 over g of negative 2 squared. F prime of negative 2. F prime of negative 2 from the table is negative 3. G of negative 2. G of negative 2 is 5 minus g prime of negative 2. G prime of negative 2 is 6. F of negative 2. F of negative 2 is 2. over g of negative 2. G of negative 2 is 5, and we are going to square that. So you have negative 13 minus 18 over 25, negative 33 over 25. All right. So the last example. It says, use the chain rule in the Leibniz notation to find dy by dx. And y is given 2u minus 3 over 3u plus 1 cube. And u is negative 2x squared. And x is given negative 1. So we are going to calculate dy by dx, where x is negative 1. All right, so dy by dx equals dy by du times du by dx. So don't think that this is dy divided by du times du divided by dx, right? So, and then you can cancel that. So it doesn't work that way. This means you are taking the derivative of y relative to u. And you take the derivative of u relative to x. Dy by du. So let's do them separately and then put them together. Okay, so this is u y. So take the exponent, put it in front as a coefficient. Keep the bracket as it is. Decrease the exponent by 1. So 3 minus 1 gives you 2. Times derivative of inside. So when you take the derivative of inside, now you need to apply the quotient rule. The derivative of numerator times denominator minus derivative of denominator 3 times numerator over square of the denominator. 3. So let's simplify this. So I'm going to distribute this square to the numerator and denominator. So 2u minus 3 square over 3u plus 1 square times. So if you simplify this, 6u plus 2 minus 6u plus 9, that gives you 11. 11 over 3u plus 1 square. So 3 times 11, 33. 2u minus 3 square over 3u plus 1 to the power of, so add the exponents. 2 plus 2 gives you 4. This is now dy by du. Now we need du by dx to take the derivative of u relative to x. So that gives you negative 4x. Then dy by dx is dy by du, which is 33 2u minus 3 square 3u plus 1 to the power of 4 times du by dx, negative 4x. If the question is asking you write everything in terms of x, you can easily replace u by negative 2x squared and then write everything in terms of x. But yeah,
what is du over dx? Like, what did you do to get negative 4x?
derivative of negative 2x squared.
Oh, okay, thank you.
So u is given as negative 2x squared. So du by dx means derivative of u relative to x. So negative 4x.
Thank you.
Yeah. Okay, now we're going to calculate this. For x equals -1. Okay, so I can substitute -1 for x, but what I'm going to do with u, right? So if x is -1, so you calculate u for x equals -1. So -2, -1 square, which is -2. So when x is -1, u is -2. That means, you know, as I substitute -1 for x, I'm going to substitute -2 for u. So 33, 2 times -2 minus 3 square over 3 times -2 plus 1 to the power of 4 times -4, and x is -1. Okay, so again, we do it for u equals -2, x equals -1. Okay, now simplify. 33, -4 minus 3 gives you -7. So -7 squared is 49 over -6 plus 1, -5. So -5 to the power of 4 times 4. If you use your calculator, 33 times 49 times 4, 6,468 over, so 5 to the power of 4 is 625.